All right. Hey Vishal. So, Hasrita, what we'll do is we'll probably close the door, but not now. I'll probably give 5 more minutes to see if anybody is coming in the classroom. Hey Anjani, not coming to the classroom, beta?
Raj is coming.
Okay. No worries. So we have one of your friend here in the classroom. That is Haswita, and she's alone. So I was seeing if we can get some. No, I'm saying Haswita, you have probably not met her. I was saying Haswita is alone in the classroom. I was just wondering if we have at least one more child joining her, but it's okay. All right. Yeah, I see somebody here. That is a good sign. Okay. So, a quick announcement before we start the class. Okay. I'm planning to launch a scholarship scheme for you guys. I'm planning to launch a scholarship scheme for you guys. Okay. Whoever makes me happy by scoring 770 plus in maths in SAT will become a candidate for whom I will sponsor this. Yeah. So Nirunya and Hasmita are only in the class, so nobody is alone here. What I'll do is I'll close the garage door so that the AC is effective. So don't worry if you see this being closed. Okay. Nirunya, can I ask you one help? There are two buttons that you see. The one above, you can press that one so that closes the door.
Online also there.
Yeah, there are kids online also. Yeah. Okay. All right.
Sorry.
Yeah, no worries. Yeah. Thank you. So let me. So the announcement that I was trying to make was that you guys have to keep working hard to learn the concepts and then make your teacher happy by scoring very well in your SAT exam. Whoever scores 780 out of 800 in maths will get a $2,000 scholarship from me. Okay? So that's the plan. I mean, see, I would not say $2,000 is a lot of money or too less of money, but it's like a motivation, right? It feels good. You feel happy that, okay, I did something and I got something, right? So that's why I'm launching this scheme. Every year I will pick 2 students whom I will give this scholarship. Because whatever money I'm taking from you guys, or your parents rather, that should go back to you guys in some way. Okay? So that I don't feel like I'm ripping off money. Okay? It should go back to you guys. Alright, so let's not worry about the money part, but I'm just trying to create motivation among you all so that you guys work towards something which you enjoy. Okay? So let's do a quick roll call and see who all we have. So we have Anjani, Davik, Dev, Dhanvin, Chris, Riya, Sahit, Sriyan, Thanu and Vishal. Okay? Thank you everybody. And here in the classroom we have Nirunya and Haswita. So let's get started. What do you see on the screen right now? Can you guys see something on the screen? Let me draw it also. What do you see on the screen? Tanu, Riya, anybody? Davik?
What's your reflection?
So basically that's the purpose of whatever I have drawn here, okay? This shape that I have drawn on the screen is only to tell me that this is the area where I should not be writing anything, okay? Because for the kids who are joining online, this is where you see maximum reflection, okay? This has nothing to do with what you're going to learn today. Now, what does this look like? The one in black. Those are
A circle.
a circle. I don't ask difficult questions always, right? Think of me asking simpler questions because one thing is for sure, I'm not intelligent, okay? I'm not intelligent at all. I might be hardworking, but I'm not intelligent. So whatever I ask you guys, assume that to be as simple as you can relate to. Okay? So this is a circle. And we have talked about circle, we talked about segment, we talked about sector, we talked about arc of a circle, right? We talked about how do we relate, how do we use unit circle trigonometry also, right? We looked at unit circle theorem, correct? Do you guys remember that or you forgot? Little bit. Okay. Riya, how about you, beta? You remember? Anjani, Saranya. Do you guys remember what we have done in the previous classes? Yeah. Okay. And whenever you tend to forget, it's very normal, it's very natural, we forget things. So you have the video always, go back to the previous class. Okay, what did we learn in the previous class? Oh, the teacher was recalling about unit circle theorem or unit circle trigonometry. What is that? I forgot. Look at the video again. That is what the video is for. Okay? Now, this attempt that I have made here to draw something on the board is a circle. Let me do one thing. Let me get rid of this reflection problem first. Give me a second. Nobody is scared, right? Nobody is scared, right? Niranya, Hasmita, no? Okay, good. Now you guys can see the board, okay? Better? Okay. Somewhat like a circle. This is nothing but a circle, no doubt. Today we are going to talk about the circle equation. Meaning, we have seen linear equation like this. You would have seen quadratic equation like this. Now we are trying to talk about a circle equation. An equation that represents a circle. Is that okay? Chris, Saranya, Anjani, any doubt with respect to what we are going to cover? Yeah, Anjani, go ahead with that.
No, I'm not.
Okay, so we are going to talk about circle equation. Now, what do we mean by a circle equation? What is the most basic way to relate what a circle equation could be? Any guess? I'm talking about this is a linear equation, okay? This is a linear equation, right? It draws a straight line, maybe like this, maybe like this. What it means is, each and every point on this line, if this is the equation, this equation represents this line, then each and every point on this line will follow this rule. Meaning the x value plus 2 times the y value will be equal to 8. Yeah? That's what linear equation stands for. Let's say if I'm talking about this equation, which is a quadratic equation. When I draw it on a coordinate plane, let's say draw something like this, a parabola. What that means is, each and every point on this parabola will, you take the x value, find out this value will be equal to this. Any point, let's say here, you pick this point, and this is, let's say, 3. You put the value of 3, value of x equal to 3. This is the value of y. So this point will have a y value of 3 square plus 3 times 3 plus 9. I'm just picking it up. Carry on. So today we are going to talk about circle equation, okay? And we are going a little bit backward to see what a circle equation would mean for us. If this is a linear equation that draws this line, that means each and every point on this line will satisfy this condition. Correct? If this is a quadratic equation and that draws a parabola for me or for us, then each and every point on this parabola will satisfy this condition. When you say any point, we are saying any point if you pick up, this any point is recognized by the x and y coordinate of that point, right? When you put the x and y value, it will satisfy this condition if these two are related. Likewise, if I am saying there is a circle equation, let me first clean it up. If I see, there is no way I can recognize anything on the board without referring to a coordinate plane. So this is my coordinate plane, this is my x-axis and this is my y-axis. Let's say I have a circle equation that draws a circle like this. And my circle equation, let's say, says x minus 8 squared plus y minus 7 squared equal to 64. If I dare to call this a circle equation which draws this circle for me, then each and every point on the circle will satisfy this condition. A moment of silence to make sure everybody is with me. Are you guys with me so far? Tanu, Sanya, Rehan, everybody? Okay, Ria. So, again, if I say I have a ux plus 3y equal to 17, let's say if I have a linear, this is a linear equation, right? Maximum power to the variable is 1. In a linear equation, let's say this draws a line like this, then each and every point on this line will satisfy this condition. Meaning, x and y value of each and every point will satisfy this condition. Similarly, if I dare to call this a circle equation, then each and every point on this circle will satisfy this condition. Make sense? This is again the very basic part, right? If I call any equation with a name, that means that equation will satisfy every point on that shape that it is drawing. Are you guys with me so far? Okay. Now let's try breaking our head a little bit more. Make sure that we do it without getting any injury. Yeah. So Nirunya is laughing at me. She will get tired of my dad jokes soon, like everybody else. So this is a coordinate plane. I can see Hasita also having similar expression, but that's fine. Okay? So this is a circle. This is a circle, okay? Now we are trying to find out how does a circle equation look like. Anybody in the class who has dealt with a circle equation in the past? Just raise your hand. Dave has dealt with it, okay? Dave, okay? So let's break it down. Okay? This is a circle. I'm saying if I have a circle equation, then that equation will satisfy every point on the circle will follow that condition. So we have to find out a formula or an equation. Since we are plotting it on x and y plane, this is x axis, this is y axis. Each and every point on this one will satisfy that formula. Okay? And we have to find out that magical formula. Let's pick up this point. Let's say this point randomly, okay? I don't know what this point is, but this has two things. These are the coordinates. Let's say this is x coordinate, this is y coordinate. Okay? What is the value of x? What you will do is you will drop a perpendicular. This length is nothing but x coordinate. Yeah? Make sense? What will be this length? Y. That is how this is x comma y. Yeah? No? No, I need to get a confirmation from you guys before I can proceed, okay? So, I have just drawn this circle such that the center of the circle coincides with the origin of the coordinate plane. Okay? Yeah? Everybody with me? And I'm just trying randomly pick a point, this one, whose coordinates are x comma y, meaning this length is x and this length is y. That is how this is x and y coordinates. Okay. Now, if I join from center to this one, center to this point, if I join this point, this will be my radius, this will be my radius, correct? Center of a circle to any point on the perimeter is my radius of a circle. Now let's look at it. Now what is the value of this arc? If you look at this triangle, this is O, and this is point A, and this is point B. The length OB, recall your uncle's formula, or my uncle's formula, Mr. Pythagoras. He gave us a formula saying if you have a right angle triangle, then the two sides making that 90-degree angle, the sum of these two sides, these side and this side are making 90 degree. So OB squared plus AB squared will be equal to OA squared. Yeah? This is a Pythagorean theorem, right? A squared plus B squared plus C squared. Riya, Dhanvin, Saranya, are you with me? Yes, Thanu?
Your voice is kind of breaking out.
Is it the case with everybody or it's only for Thanu? Riya, Davik, can you hear me
It's
okay?
not like
It's normal.
I can hear you, but
You can hear me? Who all is not able to hear me okay? Apart from Thanu.
Okay, I'll leave it.
So yeah, I mean, I was just checking it out, okay? If it's a problem at my end or it's something that you can fix by dropping off and joining back again, okay? Okay. Can everybody hear me okay right now? Anjani, Dhanvin? Okay. So, what we are trying to do is, we are trying to learn about circle theorem or circle equation, whatever you call it. Meaning an equation that can describe a circle. Meaning an equation where if I pick any point on the perimeter that fits in that equation. Okay. So what I've done is I have drawn a circle where the center of the circle coincides with the origin of the coordinate plane. Meaning where my x and y axes are matching. And I have drawn this circle. And for us to draw a circle, what do we need? Just the radius? Just the radius? As long as we know the radius, okay, 4 centimeter. Pick a projector, make 4 centimeter length and rotate it. That's how you draw a circle. So that's what we did. So we picked up this radius and put the needle here on the center of this thing, and whatever radius we wanted to choose, with that we have drawn the circle. Okay. Now I randomly picked a point here whose coordinates are x, y. And what we did, we drawn the perpendicular so that we got this as x and this as y. If x and y are the coordinates, that means this length is y and this length is x. Yeah. Now we go back to the Pythagorean theorem that says if you have now you look at this triangle OAB. This is a right angle triangle. And if you apply the Pythagorean theorem that says the two sides which is making 90 degree, which are making 90 degree, the square of this side plus square of this side will be equal to the square of the hypotenuse. Yeah. So now OB is what? X. So this is x squared. What is AB? AB is y. X squared plus y squared equal to OA. OA is what? That is my radius. This becomes the most basic form of the circle equation. Okay? For a case when your center of the circle is coinciding with the center of the coordinate plane. Is everybody with me? I see one more child dropped off. I hope it's not because of me, it's because of the network. Rehan, can you hear me okay, beta? Okay. David, Sriyan. Okay, Sriyan who got dropped off. Vishal, are you with me? Okay.
Yeah.
So this becomes the most generic form or the simplest form of circle equation. And now let's try relating it. So if somebody says, what is a circle equation? You will say circle equation is x squared plus y squared equal to r squared. Okay. Now if you fit in here, and the condition is when you have equation like this, that means the center of the circle is here, meeting with the or coinciding with the origin, and then r is the radius. You pick up any point. Let's say you pick this point, and it has coordinates x comma y. You will see that this square plus this square will be equal to this square. That's what you are seeing is the most basic form of the circle equation. Okay. So let's say this point is. Now let's assume that you are given radius of the circle is, let's say, 5. Okay, 5 centimeter. So that means your circle equation will change to x square plus y square equal to 5 square. You pick up any point here, any point. Let's say this is x comma y. So this length, I mean, what you'll see is, if you pick up this point, this point, this point, all the cases, the x and y will adjust such that the square of x squared plus square of y squared will be equal to 25. That's what it means. Yeah? Anjali, you figure it out?
Yes.
Ria, is Thanu back? Oh, I got her scared. Okay, Saranya with me? So we saw one circle equation which says x square plus y square equal to r square, where x and y are the coordinates of any point on the circle, and it is a circle which has center coinciding with this. Okay. Now let's change the game a little bit. I have this coordinate plane and this is my origin. Let's say my circle is here. Can I use the same circle equation or circle theorem? Thanu, can you hear me okay now, beta? Okay. So with whatever I was doing, what we concluded was the circle equation for a situation like this, where the center of the circle and the origin of the coordinate plane coincides. Okay. Then the circle and this is the radius. Then x squared plus y squared equal to r squared. That's what we were doing. Okay. Were you able to follow me so thus far before you dropped off, Thanu?
Yeah.
So this part is clear. Now what I'm doing is I'm moving this circle. My circle center is not on the origin. Okay, I moved it this place, and let's say this point has its own coordinates. Let's say L comma M. L is the x coordinate, M is the y coordinate. Okay, and my radius is still radius, meaning from here to any point is, let's say, same r. Okay. Can I use the same equation to represent this? David, Sahid, or Vishal, can I use the same equation to represent this kind of situation also? Thumbs up would not do. I'm asking a question. That a situation like this, when my center was coinciding with the origin of the coordinate plane, then I could use this theorem. My question is, if I move my circle such that it went to, let's say, the first quadrant, my center moved from here to here. Can I use this equation to represent this circle also? Yes, Vishal.
I don't think so.
You don't think so? You don't even have to be that political. You can say sir no, and I'm okay to accept the fact. Yes, Vishal.
No.
No. Be blunt. That's okay. Math is about being to the point. You don't have to feel or think whether your teacher will think good or not. Yes, David.
Well, I also agree. So,
You also agree with Vishal. Now I have to agree with you guys as well. This will not represent the same case. Okay? This equation will not be able to represent this because this equation says that this is a circle equation only if and only if the center of the circle coincides with the origin. Here that is not the case. Let's see what will be the right equation for this one. Let's say I have taken this point and the coordinates are x and y. Okay? Now let's look at it. I'm dropping perpendicular after perpendicular after perpendicular from every point that I can think of. So I drop a perpendicular from here to here and drop a perpendicular from here to here. What is this distance? Can somebody tell me by looking at the coordinates L, M? What is this distance? Trust me, I'm asking a very simple question, okay? Don't overload yourself by thinking too much. How much is this? Something is coming to your mouth. Say it loud. No, it's okay, but going wrong is fine. Give it a shot. The coordinates are L, M. That means the x coordinate is L. That is this distance, L. Don't be shy, that's what I'm saying. Yeah? Agree? Thanu, agree? Now, what is this distance from here to here? M, say it loud, M, yes. Don't underestimate yourself. Say it loud, going wrong is fine, not a crime. Okay, so this is M and this is L because my coordinates are L, M. Yeah, for the center. Yep. Now, this point is X, that X and Y. So if I draw perpendicular from here to here and perpendicular from here to here, what is this distance from here to here? Can somebody tell me on the screen? Yes, sir. This one.
would be an X, right?
Yep. Don't ask me question, give me answers. I want to hear a lot of confidence from you guys. Okay? Well, how about this one? Ria, Davik, Anjani, anybody? Danvin? Tanu? Yes, sir.
Y.
Y. Okay? So far I have drawn a circle where the center has a coordinate L, M, and I have just randomly picked one point which has coordinates x, y. Okay? And we are trying to find out this distance, and this distance. Okay? So this distance is M, y coordinate of this point. This distance is L, which is x coordinate of this point. Likewise, this distance is x, which is the x coordinate of this point. And this distance is y, which is the y coordinate of this point. Yeah? Tanu, Saranya, everybody with me? Okay. Alright. Sahib, with me so far? Sahib, Rehan, are you guys with me so far? Okay. Now, let's look at, so what I'm doing is I'm extending this line here to here, okay? So I'm dropping a perpendicular here so that this becomes a 90-degree triangle. 90-degree angle triangle or right angle triangle. Let's say this is O by origin, this is A, and this is point B where these two are meeting. Now this triangle OAB, when I'm saying triangle OAB, I'm talking about this red portion. Yep. OAB. This is my triangle, okay? Again, it's a right angle triangle because I have drawn a perpendicular from here to here. Then our favorite angle comes into existence one more time. Okay? This is a 90-degree angle. So here from this one you will see OB squared plus AB squared will be equal to this as per Pythagorean theorem. Yeah? OB squared A squared plus B squared equal to C squared as per Pythagorean theorem. So OB squared plus AB squared equal to OA squared. Yeah? Look at this. What is OB? OB is nothing but this distance minus this distance, correct? OB is this distance, that is this distance minus this distance, correct? And this distance is x, this distance is L. X minus L is squared, x minus L is this squared, plus AB is this much, which is this minus this. This minus this will give you this much. Y minus M squared will be equal to OA squared. OA is nothing but a radius. So this became your new, more generic form of a circle equation. X minus L square plus Y minus M square equal to R square, where L and M are the coordinates, X and Y coordinates of the center of the circle. Now, are you guys with me so far? Anjani, Dhanvin, Tanu, Sriyan, Hasvita, everybody with me so far? Yay, got so many likes. No, just kidding. Nowadays, everybody banks on those likes and views that you get on your Facebook post. So now if you compare this circle equation with this circle equation, what did we observe? In this case, my center of the circle and origin of the coordinate plane are coinciding, wherein in this case, my origin of the center of the circle is not coinciding with the origin of the coordinate plane. It has moved to some point which has coordinates L, N. Okay? And by doing this, we see that my circle equation changes to x minus L squared plus y minus M squared equal to R squared. And this becomes the most generic form of a circle equation. Meaning, even if I forget about this, I can still use this equation to find this out. Now, if you are looking at this equation as a generic equation, what you see is this is x minus L square plus y minus M square equal to R square, where L and M are the coordinates, x and y coordinates respectively of the center of the circle. Now, if you try fitting in this case, if this is a generic form, and if I want to use this form in this scenario when my center is coinciding with this one, that means what is the coordinate of this point? 0, 0. I can replace L and M with 0 and 0, and that gives me this equation. X minus 0 is x squared plus y minus 0 is y squared equal to R squared. Yeah? Tanu, Dhanvin, Anjani, Riya, Davik, everybody, Sahib, everybody okay? So now I'm going backward, meaning I'm saying that I don't want to remember this. I want to remember only one equation as a circle equation, or the standard form of circle equation as x minus L squared plus y minus M squared equal to R squared, where L and M are the x and y coordinates of the center, R is the radius. So this becomes my generic formula. Tomorrow if I am talking about a circle whose center is not here but coinciding with this, then my L and M coordinates of the x and y coordinates of the center would become 0 and 0. I can replace it here, and that gives me the formula x minus 0 is nothing but same thing, y minus 0 is nothing but same thing, equal to r squared. So x minus 0 is x squared plus y minus 0 is y squared equal to r squared. So this is a child of this parent equation, if you can say. Okay. Don't think of this equation and then go this way. Always think of this equation and substitute the x and y coordinate, and you will get this child equation, which is the simplest form of the circle equation. Is everybody with me so far? Riya, Tanu, Shreyan, Daivik. And again, I use the term L and M as the x and y coordinate. You can use h and k, you can use a and b, whatever works for you. Okay? X minus the x coordinate square plus y minus the y coordinate square, and again x and y coordinate are the coordinates of the center outside. Okay? Let's look at one problem, and then we'll see if you are able to relate it with whatever we have learned. Alright, so let's first clear it up. But is it fair to assume that everybody is able to follow what I am saying? David, Sahid, Dave, Danvit, Rehan, Riya, Tanu, Sanya, everybody? Hasrita, Niranya, everybody? So let's pick up one problem and see whatever we have talked about, is it actually making sense, or are we able to actually use it? Let me pick up one problem. This problem says a circle in a xy plane. I'm reading the question for you guys, okay? Listen to me carefully. A circle in the xy plane has a diameter with endpoints as 8, 10 and minus 2, 0. So let me. This is my xy plane. It says there is a circle which is drawn in the xy plane, has a diameter with endpoints as 8, 10. Let me do one thing. 4, 8, or 2, 4, 6, 8, 10, minus 2, minus 4, minus 6, minus 8, minus 10. Here 2, 4, 6, 8, 10, minus 2, minus 4, minus 6, minus 8, minus 10. It says the circle in the xy plane has diameter with endpoints at 8, 10. So 8, 10. 8, 10. Let me make it 4, 8, 12, 16, 20. I'm changing the scale, okay? So that 4, 8, 12, 16, 20. Diameter has endpoints at 8, 10. So 8, 10, somewhere here. This is one endpoint of diameter, and minus 2, 0. So minus 2, 0. So this is the second point. Which of the following is the center of the circle? So your circle is somewhere like this. This is your circle, okay? Which has diameter endpoints at, this is 8, 10 and minus 2, 0. So the question says, you have a circle in the xy plane where the two endpoints of a diameter are 8, 10 and minus 2, 0. Which of the following is the center of the circle? So basically you have to find out the coordinates of the center of the circle. Let's say this is x, y. You have to find out the coordinates of the center. And you are given 4 options. 5 comma 3, 3 comma 5, 5 comma 5, 6 comma 10. So I'm repeating the question one last time, okay? And then we'll not try solving it immediately, but I would rather want to see the approach that you guys have. We are given that this is circle in the coordinate plane, this is a coordinate plane, where with the diameters end points being 2, 0 and 8, 10. We have been asked to find out the coordinates of the center, and we are given 4 options. Which one is the likely answer for this one? Did everybody hear the question completely? This is a coordinate plane, this is a circle, the 2 end points of a diameter is given to us, 8, 10 and -2, 0. We have been asked to find out what is the coordinates of the center, and we have 4 options. Now tell me, first of all, did everybody hear the question okay? Okay. Now, I want to know what is going in your mind. How would you find this out? Don't try to give me the answer. Tell me how would you find it out. Give me an approach. Here also. Think about it and tell me. And there is no wrong approach, okay? And there is no wrong answer either. Tell me what will go in your mind to come to the conclusion. Riya, Anjani, Dhanvin, Vishal, Dave, Daivik, everybody, Tanu. And everybody whose name I have not called out. What is going in your mind right now? Yes, Dave?
I'm about to go by like 350 or 355 instead of that.
Yeah, that's really fine.
Okay.
But before you go, tell me what is going in your mind. How would you find this out? Dave, Tanu, everybody. I'm sorry? Okay, okay. Give me guys some guiding principles, okay? I mean, at least give me a jump start. Tell me how should I start? Riya, any clue, beta? Thinking? Vishal? Okay. Any thoughts? Random thoughts. See, I can bet that you guys have better drawing skills than me, okay? And this question is all about drawing. Okay? Or now let's look at it. It's very simple, okay? Let me erase all the options. What I will do is, I will drop a perpendicular from here to here. So 8, 10, that means this distance is 8. Yep. And this one is -2. So from here to here is also 2 in the negative direction. Yeah. And drop a perpendicular from here to here. This distance we don't know. I am calling it x. Yeah. Similarly, drop a perpendicular from here to here. This distance is given as 10. Yeah. Now, from here to here, the two, see, look at this. This part is the center. Whatever is this whole distance, here to here, whatever is the distance, right? this will be okay. I'm just thinking which approach we should take. I can say this whole distance divided by 2. So I can apply 2 approaches. One is, do you guys recall or remember the concept of similarity of triangles? When 2 triangles are similar, their sides are in the same proportion. Yeah? Remember? David, do you recall? When you have 2 triangles which are similar, then their sides will be in the same proportion. Now look at this triangle and this triangle. They are similar because this angle is common and these 2 are parallel lines. So this angle will be same, and this and this are 90 anyways. So let's say this is OAB and this is C and D. So if I say triangle OAB and triangle OCD, they are similar. Yep, because this angle is common, this angle and this angle will be same because parallel lines. And when you have it's called corresponding angles, right? So you have 2 parallel lines and this is the intersecting line. So these are called corresponding angles. These 2 will be same and these 2 are angle 90 degrees. So they are similar. Do you guys agree or you don't? Okay. So these 2 are similar triangles. That means the sides will be the same ratio. Now, this side is how much? From here to here. It is here to here is x and this is minus 2. So x plus 2. X. This distance is x and this distance is minus 2. So x minus 2. Or just look at the absolute distance. This is 2 and this is x. So x plus 2 is this length. What is this length? This is this is 8 plus 2. So OB by OC. So OB is x plus 2 and OC is 8 plus 2, 10. Will be equal to x plus 2 is this length. So I will take this one. This one is y divided by this is y divided by this distance, which is this is 10. Yeah. So x plus 2 equal to y. This is one equation we have got. Now I'm just thinking there's a simpler way of doing it. Okay, yeah. Now, one more thing. Okay, let me solve it here. This distance is x plus 2. So this divided by this is 10 will be equal to this divided by this length, and this length is radius by this whole length is 2 radius. Yeah. So x plus 2 divided by 10 is equal to 1 by 2. So x plus 2 equal to 10, or 2x plus 4 equal to 10, 2x equal to 6, x equal to 3. Now everybody must be thinking that, okay, what did we do? So let me first find out x and y value and then we'll come back to it. clean it out. So I'm repeating the question again, okay? This is the circle given to us. This is x and y plane. This is a circle with diameter 8, 10 as one end point and minus 2, 0 as the second end point, and this is the circle we are talking about. Let's say this is minus 2, 10. Okay? We are trying to find out the coordinates of the center. Okay? Is this part clear so far? That this is what we are trying to find out. We are given that there is a circle in the coordinate plane with the two endpoints of the diameter as 2, 0 and 8, 10, and we have to find out the coordinates of the center. Yeah? What we are doing is dropping a perpendicular from all these points. So this is O, let's say this is A, B, and this is C, and this is D. What we know is, if you look at triangle OAB and triangle OCD, meaning this triangle and the larger triangle, okay? We have to find out x, y, meaning we have to find out this length. Okay, we don't know that. We have to find out this length which we don't know right now. We are trying to find out from the relationship so far. Okay. So this is my small triangle, this is my large triangle, and when I look at them, I find that both are similar. They are similar because this angle is common in both of them. This is 90 degree, this is 90 degree. Third angle has to match any which way. Yeah? Are you guys with me? Vishal, Dave? Ria? Thanu? Anybody? Okay. So these are two end points of the diameter. This is the center which we don't know what the coordinate, that's what we have to find out. And this coordinate is minus 2, 0, this coordinate is 8, 10. And we have to find out the coordinates of the center. What we are doing is, we are just dropping perpendicular from here onto the x-axis, here onto the x-axis, and we can drop perpendicular from here to the y-axis. This distance will be 10 because the y-coordinate is 10. Here to the y-axis, this distance will be y, and here to here this distance is x. We have to find out x and y. Now when we look at this triangle and this triangle, they are similar because this triangle is common in both the triangles, and these two angles are 90 degrees. So third angle has to match any which way. So they are similar. When they are similar, we know by similarity principles that when two triangles are similar, their sides are in the same proportion. Okay? Sides meaning sides opposite to the matching angle. So this is the common angle or matching angle in both the triangles. Side opposite to this distance, y by this distance is nothing but 10, is equal to, let's say, second angle, this angle and this angle. This angle in this triangle, this length is nothing but the radius. This angle, this is nothing but the 2 times the radius. Yeah. So from this, r and I need to do tic-tac-toe, y, and then you can do butterfly, 10 goes this side, y equals 10 divided by 2, you got y equal to 5. Yeah? Vishal, am I confusing you guys? Are you with me? And yeah, but
I was in here for like 10 minutes. I just came back. If I understand.
you understand? Okay. Anjani said thumbs up. Dhanvin, are you clear with her? Yeah. Tanu, Ria, everybody? Saranya? Okay. So I did nothing. I just have drawn these 2 points, drawn perpendicular so that this becomes right angle triangle, this becomes right angle triangle. What we found that they are similar, so if they are similar, their sides will be the same proportion. I picked up this angle first, looked at this side versus by this side. That ratio will be equal to second angle when I pick up. This angle's opposite side is this one, which is radius, and this angle's opposite side is the whole diameter. So from that we got y equal to 5. Now you can look at the third ratio also, which is this divided by this, which is opposite to this angle. These two angles also matter. So this side is this distance x plus 2, x plus 2, this whole length, we talk about the length, okay? Divided by this whole distance, which is 2 plus 8 here, so 10. So from this you got y equal to 5, and when you look at, you put the value of y equal to 5 here, so x plus 2 by 10 equal to 5 by 10. So x plus 2 will be equal to 5, x will be equal to 3. So your coordinates are x comma y. X is 3, y is 5. Does that make sense? Stressful, but right? Not easy to digest. So look, see, this is one way of doing it. Okay. Now, the second thing that you can look at is, look at this whole distance. This whole distance is going to be double of this distance. This distance is nothing but, here to here is 8 plus 2, 10. This will be half, so it will be 5. But this distance is 5, but 2 is already consumed here, so 3 is what you will have. That is one way of looking at it. You can also apply Pythagorean theorem, but summary here is from this picture, okay? Now let's take a step back. When we had a circle given, we know what is the diameter, right? We know diameter is 2 times the radius. We just drew it on the screen, on the board or piece of paper, whatever it is, and we put the point. Now we are trying to find out, okay, what is the coordinate? I cannot just do this divided by 2 and then this divided by 2. That will not be correct. What we did was, okay, fine, let's draw a circle, let's draw perpendicular, look at it like a coordinate plane, and then we found, okay, there are two triangles which are similar. So when the triangles are similar, the sides will be in the same ratio, proportion. And we have just applied that to be able to find this one. Okay. Wait, you are probably okay. Almost time for the class, so I will probably wrap up this class then before we start. Just give me a minute. I'll open the door here. So before we start the class for dead kids, okay? Whatever we have tried doing, okay? I mean, we have just touched the tip of the iceberg so far. What we did was we just tried looking at what is a circle equation. We tried finding out a standard form of circle equation also, and then we tried relating that with how that equation changes if my origin is at the center versus the origin is somewhere else. Okay? And then we are trying to solve it or apply the circle equation to find out the coordinates of the center. It was not relating to the circle equation directly, but more to do with the geometry understanding and the understanding of the coordinate planes. We'll deal with more problems in the coming class so that we practice a little bit more. But here, if you look at it, we have not dealt with the problem. Look at the circle equation so far. It was only to see how do we relate our geometry concepts, how do we relate it with the concepts around similar triangles and the ratio of the sides to find out the coordinates of the circle. We'll deal with more problems in the coming class. Tomorrow we'll probably muddle the water a little bit more, practice some more problems, and that should clear a lot of dust for us. But was it clear to you all before I happily let you guys go? Okay. Then more struggle, more fight, more fun tomorrow, okay?